We're used to measuring angles in degrees. We can also start talking about angle measurements in radian measure. So just as a quick review, take a look at this illustration on the right. Suppose we have a circle with a radius of 1. So this radius is 1, and to point S, that means this radius is also 1. If we happen to create an angle such that this arc length also has a measurement of 1, the angle created we would call 1 radian. 1 radian is approximately 57.296 degrees. And since that conversion factor isn't the nicest to work with, there's other relationships that we can use to convert between degrees and radians. Degrees and radians both measure angles, so let's build some fluidity between the two different angle measures. We can see here that 180 degrees is the same thing as saying pi radians, just in different units, much like we would say something like 12 inches is equivalent to 1 foot. So we can use this as a conversion factor, and also we can make other conversion factors out of it. I could say, well, if 180 degrees is pi radians, then 360 degrees is 2 pi radians. Similarly, I could say that 90 degrees would be pi over 2 radians. So let's use these conversion factors here. Pick whichever one you like, but most commonly we would use 180 degrees as pi radians. So if I know that I have 210 degrees and I want to turn that into radians, I'm going to take 210, I'm going to multiply it by its appropriate conversion factor. So since I want to turn this into radians, I'm going to put the radian measure on the top and the angle measure on the bottom from our comparison fraction. So 180 degrees is going to go in the denominator. Now, something that I think is neat to look at, when we multiply straight across, we're going to get 210 degrees times pi radians over 180 degrees. Now, this may seem strange here, but what we're actually going to be able to do is to look at our units and see that degrees as a unit is going to cancel. That's pretty neat. So now I'm just going to multiply straight across the top and reduce my fraction as much as I can. So 210 times pi radians, 210 pi radians over 180. And it's not 180 degrees anymore. So reducing this would be 7 pi sixth radians. And I want to be really careful. It's not 7/6 radians, it's 7 pi sixth radians. So if I wanted to, I could multiply 7/6 times pi and come up with approximately 3.665 radians. But as we're going to be reminded here in a moment, it's much nicer to be able to count around our unit circle and in fractions of pi, as opposed to trying to estimate just by glancing where 3.665 radians is. But I think it's good to have both of those looked at. So let's go the opposite direction now. Suppose I want to take 5 pi fourths radians and I want to turn that into degrees. I'm still going to multiply by the same conversion factor, but this time, since I want my answer to be in degrees, I'm going to put the degree measure, 180 degrees, on the top and pi radians in the denominator. Now, I will show more work on this one than maybe I need to, but I think it's helpful at first. So this would be 5 pi radians times 180 degrees over 4 pi radians. And I can see here that things are going to cancel with one another. I'm going to be able to reduce pi divided by pi. That's just 1. And our units of radians are also going to disappear. So all I'm left to do now is calculate 5 fourths of 180. And 5 fourths times 180 will get me 225 degrees. So 5 fourths radians is the same thing as saying 225 degrees, just different units of measurement. Your turn. 140 degrees. Change that to radians. 7 pi halves radians. Change it to degrees. 630 degrees.